this is it installed, and I take everything out and look at the difference. No problem, no error codes. So the secondary air injection system takes air from your inbox. A solenoid valve allows that air to pass through when needed into the cylinder heads, and it enters the exhaust system where there's a chemical reaction with the fumes to reduce the toxic emissions according to the EU, and that also helps heat up the catalytic converter quicker. This is usually occurring at startup, and in order to replace it, we simply need to plug in the airbox, plug in the cylinder heads, or cap them off if possible. I'll talk about that in a second. And replace the solenoid valve with a resistor, which has tucked its way into here. And that resistor fools the ECU into believing that the solenoid valve is still connected. You won't throw any errors. More about that resistor in a second. And this came around here and connected to the solenoid valve. So this is where we're going to install our resistor. In order to determine which resistor you need in order to fill the ECU, grab a multimeter, measure the resistance across the connections that would normally connect to the solenoid valve. And that resistance, you basically only need to go over that value. So if anything over that value, it has that threshold. It's not necessarily a band that it needs to operate within. Now, when you order a resistor, it's going to have a resistance value, and it's also going to have a power value. So that's the maximum power that it can take. So this is the resistor installed. To explain it better, this is a 270 ohm resistor. Now, the solenoid valve has a 22 ohm resistance on the Daytona 660, and it's usually around that for most bikes. So why would I go for a 270 ohm resistor? Well, 270 ohms at 12 volts draws around half a watt of power. But this has a 3 watt capacity. So I'm well within range. It's not going to get too hot and burn out. Now, the motorcycle normally operates on a 12 volt system. So to make sure that you have the right resistor with the right power value, either look up the equations and do the math, or go to a resistor calculator online. What I'm doing is bending over the arms and then just curling around the end a bit so that it's thicker, and I have them overlapping on the side as well, so they're thicker in both width and depth. And then that actually just plugs neatly into the connector on the bike for the solenoid valve. After that, I'll wrap it up. I'll put some shrink wrap tubing on it. It should be good to go. Just a little note on soldering the resistor in. Some people will do that. It's probably fine, but I remember, I think it was Porsche did a study on their rally specific build, and I think they discovered that soldering connections isn't the best when there's a lot of vibration, because the solders will crack. So I'm happy having a tight fitting squeeze that's able to move around a little bit with the vibrations. So that hose and solenoid valve system that I was showing you just a minute ago, at the end of the hoses you have these caps. These are the caps that I was talking about that go into the cylinder heads. Now these caps, they sit on top, and right beneath them you have reed valves. And what they allow is the air to flow into the cylinder head, but they don't allow air to flow back through into the airbox. Normally what people do is they take these caps off, they take the reeds out because they can make a buzzing sound sometimes. I don't really notice it, but some people do. And they have, say, an aluminium CNC milled cap without the outlet or inlet, and they just bolt that on using the original rubber seal. So if you can go online and find those caps, that's one way of doing it. In my case, I can't find caps for my Daytona 660 where I am, and this is just a cheap, easy way of doing it anyway. I'll keep the reed valves in, I'll use the original caps, and I'll just block them off with these hose caps. Just a few little tips. Use your calipers to size how big the internal diameter of your hose caps need to be, and then make sure you get clips. This is one kind of clip I had left over from the CRF. You can also get these bad boys. Get them cheap, you get a set of them. And I recommend you get this hose tool as well, this clip tool. And it ratchets, so it'll hold it open for you. So just to show you quickly, this is where the caps were bolted on. This is for 2 cylinders and this is for 1, and you have 1, 2, 3 reed valves. Maybe you can hear them. A note on the solenoid valve, there are 2 parts to it, mechanical part with a plunger rod that closes the flow of the system, blocks the flow of the system, and then the top is the electronic part, the electrical part, and that has copper wound. When the current flows, it creates a magnetic field which pulls it open, allowing the flow through. Now that one is called normally closed because when it's not active, the plunger is down, closing the flow, blocking the flow. There are other types where they're normally open. So normally the plunger is up and the field is activated. Using the magnetic field, it pulls the plunger down, closing it. So I'd like to give a disassembly tip. I recommend unplugging, getting out of the way everything that you can from around the area that this is installed. Then taking this out as one piece so that these caps are still plugged into the hose. And then you can start working on pulling these off. Now, the problem is that these clips, you can't just open it, pull it back, let it go, and then pull out the cap because there's not enough space. So before, I didn't have one of these, which I recommend getting. Just buy a cheap hose clip clamp. That's the best solution. But if you don't want to do that, fine. What I did was I called my wife. You might need to get a wife or a clamp of some sort. Hold that open. They're stubborn anyway, so I got a little flathead. I poked it in, lifted it up a tiny bit, sprayed some WD-40, started twisting it around and just yanked it out. You got to give it a good pull and it pops out. So I thought I'd show you what it all looks like when everything's installed. And the main point of me doing this is just to clean things up, make the bikes neater. This is it installed, and I take everything out and look at the difference. Just to show you quickly where the hose led to the airbox right here. So I'm just plugging it up now and we're good to go. So this is the finished product, much neater than before. Highly recommend doing it. And the Daytona 660, there's a little bracket to add here that helps hold the airbox. To show you here, I just decided to tape it up. I'm going to zip tie the end of the tape so it won't unravel, and I'm going to tuck it back here because dirt actually does get in here, dirt and water. I'm going to get that fuel pump running a few times. Turned it on, turned it off a few times to get the fuel pump working. Started it up, no problem, no error codes.